Welcome to Mind to Your Learning, where we make GCSE learning and revision easy. In today's GCSE Maths lesson, we're introducing linear inequalities. So far, you may have solved equations where the aim is to find one exact answer. But inequalities are slightly different. Instead of finding one value, we often find a whole range of possible values. By the end of this lesson, you'll understand how to read inequality symbols, solve simple linear inequalities, and avoid one of the most common mistakes: forgetting to flip the inequality sign when working with negatives. Before we begin, remember to like this video, subscribe to Mind to Your Learning, and follow along carefully. By the end of this lesson, you should be able to identify and interpret the four main inequality symbols. You will learn how to solve linear inequalities using similar methods to solving equations. You will understand when and why we use the negative flip rule. Finally, you will compare equation solutions with inequality solution sets. The key idea today is that inequalities do not usually give just one answer. They describe a range of values that make a statement true. Let's begin with the key vocabulary. An inequality is a mathematical statement showing that two expressions are not necessarily equal. A solution set is the entire range of values that make an inequality true. An integer is a whole number that can be positive, negative, or zero. For example, -3, 0, 4, and 12 are all integers. These words matter because when solving inequalities, we often need to describe more than one possible answer. Before we move into inequalities, let's quickly recap solving equations. The golden rule is, whatever you do to one side, you must do to the other. For example, if we solve 3 bracket x minus 4 bracket equals 18, we first expand the bracket. That gives us 3x minus 12 equals 18. Then we add 12 to both sides. So 3x equals 30. Finally, we divide by 3. That gives x equals 10. We'll use very similar steps when solving inequalities. Let's do a quick recall quiz to check your equation skills. Question 1. Solve for x. 2. X plus 5 equals 15. Question 2. Solve for x. 4 bracket x minus 2 bracket equals 12. Question 3. Solve for x. 5. X minus 3 equals 2. X plus 9. Pause the video and try all three before checking the answers. Let's check the answers. For question 1, 2x plus 5 equals 15. Subtract 5 from both sides to get 2, x equals 10. Divide by 2, so x equals 5. For question 2, 4 bracket x minus 2 bracket equals 12. Expand the bracket to get 4x minus 8 equals 12. Add 8 to both sides to get 4x equals 20. Divide by 4, so x equals 5. For question 3, 5 x minus 3 equals 2, x plus 9. Subtract 2x from both sides to get 3x minus 3 equals 9. Add 3 to both sides to get 3x equals 12. Divide by 3, so x equals 4. In real life, things are not always exactly equal. Think about a speed limit. If the speed limit is 70 miles per hour, can you drive at 60 miles per hour? Yes. Can you drive at exactly 70 miles per hour? Yes. Can you drive at 71 miles per hour? No. So, the rule is not that your speed must equal 70. The rule is that your speed must be less than or equal to 70. Mathematically, we write that using the symbol less than or equal to. So, speed is less than or equal to 70. The good news is that solving linear inequalities is very similar to solving equations. We still use inverse operations to isolate x. Let's look at the example. 4 x plus 7 is less than 19. First, subtract 7 from both sides. That gives 4x is less than 12. Then divide both sides by 4. That gives x is less than 3. So the solution is not just one value. It means any value less than 3 will make the inequality true. Let's check your understanding. Solve the inequality. 3x minus 5 is greater than or equal to 10. Is the answer x is greater than or equal to 5? X is greater than or equal to 1.6. X is greater than 5. X is less than or equal to 5. Pause the video and solve it carefully. Remember to use inverse operations just like solving an equation. The correct answer is x is greater than or equal to 5. Here's why. Start with 3x minus 5 is greater than or equal to 10. Add 5 to both sides. That gives 3x is greater than or equal to 15. Then divide both sides by 3. So x is greater than or equal to 5. We keep the greater than or equal to sign because we divided by positive 3, not a negative number. Now, we come to the most important warning in this lesson. When you multiply or divide both sides of an inequality by a negative number, you must flip the inequality sign. For example, negative 2x is less than 10. To solve this, we divide both sides by negative 2. Because we divide by a negative number, the inequality sign flips, so x is greater than negative 5. If we forgot to flip the sign, the answer would be mathematically incorrect. Let's understand why the sign flips. Start with a simple true statement. 1 is less than 3. Now multiply both sides by negative 1. The numbers become negative 1 and negative 3. But on a number line, negative 1 is actually larger than negative 3 because it is further to the right. So the correct statement is negative 1 is greater than negative 3. That is why multiplying or dividing by a negative reverses the inequality. Now, let's compare equations and inequalities. An equation usually gives a single point or specific value. For example, x equals 4. Only 4 works. An inequality gives a region or set of possible values. For example, x is greater than 4. That means values like 4.1, 5, 100, and even 1 million all work. So equations often give exact answers, while inequalities describe ranges. Let's try the final challenge. If 2x plus 4 is less than 10 and x is an integer, what is the largest possible value x can be? Pause the video and solve the inequality first. Then remember that x must be an integer, which means it must be a whole number. Let's solve it step by step. Start with 2x plus 4 is less than 10. Subtract 4 from both sides. That gives 2x is less than 6. Divide both sides by 2, so x is less than 3. Now we need the largest possible integer, less than 3. Because the sign is less than, not less than or equal to, x cannot be 3. So the largest possible integer is 2. A common mistake is to say 3, but 3 does not work because the inequality says x must be less than 3. Today, we have moved from finding specific answers to finding ranges of values. The 4 main inequality symbols are less than, greater than, less than or equal to, greater than or equal to. The method is very similar to solving equations. Balance both sides and use inverse operations. But remember, the danger zone. When you multiply or divide by a negative number, flip the inequality sign. In the next lesson, we will learn how to represent inequality solutions graphically on a number line. That's the end of today's lesson on linear inequalities. You should now understand how inequalities describe ranges of values, how to solve them algebraically, and why the sign flips when multiplying or dividing by a negative. Remember, equations give exact values, but inequalities give solution sets. If this lesson helped, please like the video, subscribe to Mind Tier Learning, and watch the next GCSE Maths lesson to keep building your algebra confidence.